Welcome to the section of this course. Today I will be speaking about different types of methods for integral. That's called Weierstrass substitutions of integral. Okay. So in this integral, it is most of the function of either sin x or cos x, or it may be both. Okay. In these type of functions, if it is somehow difficult to solve the integral, okay, in that we have to use this type of standard substitution. Okay, these are all standard substitutions. In this substitution, what we have to do is we have to substitute t equals to, say, tan of x upon 2, this half angle. Okay, now from there what you have to do, you have to find, okay, from there you have to find sin x, and you have to find what? Cos x. If the integral contains only sin x, then you have to use sin x. If integral contains cos x, and then only you have to use cos x, and then obviously you have to find dx. Okay, now from here, how to find all this? Okay, now if t equals to, you have to substitute this. Okay, if t equals to 10x by 2, it means what? Okay, it is what? It is right angle triangle. Okay, it is right angle triangle. Here 10x by 2. Okay, here this is what? Here is x by 2. Okay, x by 2. Okay, now here 10, this is same as, you can say it is same as 10x by 2 is same as t upon 1. I can say t is same as t upon 1. Okay, now this is height, or sometimes this is called altitude. Okay, altitude. This is called base. This is hypotenuse. Okay, it is a right angle triangle. Now 10 of x by 2 means t by this by this. For example, this O A B. Okay, O upon BO is what? 10x by 2. Okay, 10x by 2. It means here this will be what? This will be, this side, the length of this side will be what? T, and this side will be what? We have 1. Okay, now this upon this is what? 10 of x by 2, this angle. Okay, now if I want to find this side, okay, this is what? Pythagorean theorem. This square, hypotenuse square is same as this square plus this square. Okay, therefore if I want to find this is same as, this will be what? Square root of t square. So I will write by red pen. This will be square root of t square plus 1 square is same as 1. This side by Pythagorean theorem. By Pythagorean theorem, what says? Hypotenuse square means, by Pythagorean, what we said? AB square is equals to BO square, OB square plus OA square. Okay, now what is OB? OB is what? We have 1. 1 square is 1 plus this is what? T square. This AB we 1. Okay, therefore this 1 plus t square is same as t square plus 1. Okay, this is what? My AB. Now if I want to find, therefore AB equals to square root of t square plus 1. This is what? Here. Okay, now we have this. Okay, we have all this. We have this side, this side, this side. Okay, now similarly sin of x is same as what? Sin of x I can be written as, we have sin of 2x is what? 2 sin of x cos x. Okay, now if I want to bring back this, since x is there, I need to break x by 2, because over here this triangle is for x by 2. If it is 90, then this will be 90 minus x by 2. Okay, therefore if I want to get, I can write like this: sin of x is same as sin of, in terms of 2, 2 into, I can say 2 into x by 2, because 2 gets cancelled, therefore sin x is same as sin 2 into x by 2. Okay, why I have written? Because I want to get into this angle from. Okay, sin 2x formula we have, sin 2x is what? 2 sin x into cos x. Okay, this is same as 2 sine of what? It will be what? X by 2 into cos of what? X by 2. Okay, now we'll solve this later on. Therefore, okay, therefore 2, okay, what is sin x? Okay, sin x is what? This upon this. Okay, this upon this means sin x by 2. Okay, in this triangle sin x by 2 is altitude upon hypo. Okay, therefore this is what? Altitude is what? T upon square root of t square plus 1 into cos x is base upon hypotenuse. Base is what? We have 1 upon hypotenuse square root of t square plus 1. Okay, 2 we have sin x by 2 is sin x by 2 if in this triangle A, B, O, if I want to get sin x by 2, then sin x by 2 is this upon this, altitude upon hypo. Okay, this leg is what we have? T upon hypotenuse is square of t square plus 1. Similarly, cos x by 2 is what? Base upon hypotenuse. Base is what we have? 1. Okay, 1 upon hypotenuse is square root of t square plus 1. Now this is same as 2 into t into 1 is 2t. Now square root of a into square root of b is same as square root of a into b. Okay, so I can write like this. This is same as t square here plus 1, or you can say if it is same, or you can say square root of a into square root of a is same as square root of a the whole square is same as a into half, because square root of half, square root is what? A raised to half. Okay, into 2 gets cancelled, we have a. Okay, or otherwise you can say if base are same, you can add the power. Okay, or you can say since this is half and this is half, this raised to half, this raised to half, half plus half is what? 1, you can say. Okay, therefore what we'll have? We'll have only t square plus 1. Okay, this is your sin x. Okay, therefore we have in the, if I substitute this, then sin x I'm having this. Okay, this is my sin x. Now what about cos x? Okay, what cos x? Okay, now cos 2x formula we have of cos of 2x. Okay, we have cos of 2x equals to, we have cos square x minus sin square x. Okay, or this is same as 2 cos square x minus 1, or this is same as 1 minus 2 sin square x. Okay, now from this any of the three formula we can use it. Okay, but instead of cos x, what we have to write? Same as over here, cos of 2 into what? X by 2, because 2 gets cancelled, x equal. Why I'm bringing x by 2? Because this triangle is x by 2. Since I already substitute t equals to 10x by 2, I need to get all angles into x by 2. Okay, now let's take first one. Okay, first one is what? 2 cos x, cos 2x is cos square x. Here cos square x by 2 minus sin square x by 2. Okay, what is cos square x by 2? Okay, cos square x by 2. Now what is cos x? Okay, from here you can see cos x is what? From this triangle, cos x is this upon this. Okay, here we have 1 upon square root of t square plus 1 the whole square minus sine square is what? This upon this. T upon square root of t square plus 1 the whole square. Okay. Now square root and square gets cancelled. What we have is 1 upon square root of t square plus 1 minus this square is for this also, for this also. If I separate, this will be what? T square upon square root and square gets cancelled. I will have t square plus 1. Okay. Now if I take LCM, denominators are same, so I can write 1 here t square plus 1. Since denominators are same, so we can keep 1 minus t square. 1 minus t square, or you can say the same as 1 minus t square upon 1 plus t square. This is for your cos x. Okay. So if I can write, since if it is this, we can write like this. Sin x become, what is sin x become what? 2t upon t square plus 1. Okay. And similarly, cos t equals to, what is cos t? 1 minus t square upon 1 plus t square. Okay. But this should be x. Okay. So this is x. So now we have sin x, cos x. Okay. We need to get what? dx. Okay. So our aim is to 1. If t equals to sin x by 2, then we need to have sin x in terms of t, cos x in terms of t, and dx in terms of t. Okay. Now in order to find dx, okay, from here you can say that x by 2 is equals to tan inverse t. Are you agree? If t equals to tan x by 2, okay, then x by 2 will be what? Tan inverse of t. Okay. Therefore, it implies I want to get only x. I can send these two there. Okay. Here 2 into tan inverse t. Okay. Now differentiating with respect to, okay, differentiating, so we have, now differentiating, we have x will be what? We'll get dx is equals to 2 is constant. Okay, differentiation of tan inverse x is what? 1 upon 1 plus t square. Okay, or therefore dx is same as 2 upon 1 plus t square. Okay, dx is, you can get like this. Okay, so therefore dx we have, I will write here, dx equals to 2 upon 1 plus t square. Okay. So by using what? By using substitution, t equals to tan x by 2. Okay. From there, what you have to do is from there you find all sin x, whatever you have in terms of t, cos x in terms of t, okay, and dx in terms of t, and you solve it that integral. Okay, that will be somehow easier. That integral will be somehow easier. Okay. Now let's take some example for Weierstrass integral. Okay. Now I already explained to you this type of integral. Okay, we have to put standard substitutions. Okay, where we have to substitute t equals to tan x by 2. Okay, from here I already explained in the previous lecture how come sin x equals to 2t upon 1 plus t square, cos x equals to this, as well as dx equals to this. Okay, this derivation I already explained into the previous lecture. Okay, if you want, you can check in the link below. Okay, the how to prove all this. Okay, now this is a question. Okay, integral cos x upon 1 plus cos x dx. Here we have only cos x. Okay, so now we have to use cos x and dx. Okay, therefore this is same as integral what is cosx. Cosx is what? Now I'm substituting t equals to, you can say, putting, you need to write this, putting t equals to 10x by 2. Therefore, dx equals to 2 upon 1 plus t square. Okay, this I am writing directly. How come from here, how come from t equals to x by 2, how come dx equals to 2 upon 1 plus t square? You can check, I told you in the previous lecture. Okay, and therefore sine of, here we need only cos x. Okay, here cos x is what? 1 minus t square upon 1 plus t square. Okay, now substitute over here. This become integral of cos x is what? 1 minus t square upon 1 plus t square. Now upon 1 plus cos x is 1 minus t square upon 1 plus t square into, what is dx? Dx is into 2 upon 1 plus t square. Okay, now if I take LCM over here, if I take LCM here, if I take LCM, okay, this 1 minus t square, this 1 plus t square and 1 plus t square gets cancelled. I write here 1 minus t square upon 1 plus t square. I take LCM here, 1 plus t square plus 1 minus t square upon 1 plus t square into 2 I can send outside, 2 upon 1 plus t square. What I am doing is, thus I am taking LCM. Okay, here 1 plus t square, 1 plus t square gets cancelled. Okay, here what we have is this upon this. Okay, as well as t square minus plus t square minus t square gets cancelled, is equals to integral. Here it should be in terms of here dt. Okay, here it should be dt, here it should be dt. Okay, what we have is 1 minus t square upon, okay, this one gets cancelled, plus t square minus t square get cancelled, 1 plus 1 is 2. Okay, here I have 1 2, here 2, 1 plus 1 2 into, okay, here 1 plus t square, I can write here 1 plus t square into dt. Now these two gets cancelled. What I have is integral of 1 minus t square upon 1 plus t square dt. Okay, now we have standard formula. Okay, now this can be written as, you can divide this by division algorithm. Okay, or what you can do is you can divide this upon this or this upon this. Okay, let's see. Even if you want, you can divide this upon this. This is same as, I can say, if I am separating this 1 upon 1 plus t square dt, separating, minus t square upon 1 plus t square dt. Or otherwise you can do one thing, you can divide here 1 plus t square 1 minus t square. Okay, so if I write 1 here, okay, here it should be, otherwise what you can do is you can write here, instead of 1 plus t square, you can write t square plus 1. Instead of 1 minus t square, you can write minus t square plus 1. Okay, now if you want to get cancelled, you have to multiply by minus. Okay, here you will get minus t square minus 1. Okay, here these two gets cancelled, because if I multiply by minus, this minus and this minus minus plus gets cancelled. Here what will get? Minus minus plus. Here we have 2. Okay. Otherwise you can do one thing. This is same as what? Remainder is what? Remainder is 2. Okay. Here minus 1 plus 2 upon t square plus 1. This is dt. Okay. You can solve this way. Here, this way. Here you can apply a square plus x square. Okay. Here again you have to substitute. Now by division algorithm, this will be much better. Okay. So let's remove this. Let's remove this one. Therefore, okay. Once again you can say over here, how come 1 plus t square become t square plus 1? Because a plus b is same as a b plus a. In plus, no problem. Okay, here t plus 1. Here minus t square, here minus t square plus 1. So minus 1 I have to write, if I minus 1 minus t square plus minus minus. Okay, minus we have to multiply. This become a plus, this gets cancelled, minus minus plus 1 plus 1 is 2. Okay, this is remainder. I am writing over here minus 1 over here. Otherwise you can check over here. If you take LCM, what will get? Minus t square plus 1. Okay, plus 2. This is denominator, this numerator. Okay, here you can say minus t square. Okay, here will be what? If I multiply this, minus t square minus 1. Okay, if you multiply this will be minus t square plus minus minus 1 plus 2. Here you will get minus t square plus 1. Okay, therefore this is same as what? If I integrate this, integral of minus is what? I will get only minus t plus. Okay, now 2 I can send outside. 1 upon t square plus 1 square dt. It is of the form what? Integral of 1 by a square plus x square is 1 by a tan inverse x by a plus some constant. Okay, now apply here is equals to minus t plus 2 1 by a. Here 1 by 1 is 1. Tan inverse x by a. Here t upon 1 is t plus some constant. Okay, now t you have to bring back. What is t? T is what? 10x by 2. Therefore this is minus 10x by 2 plus 2 tan inverse 10x by 2 plus c. Okay, here you can write 10 inverse and 10 gets cancelled. This is as minus 10x by 2 plus 2x by 2. Okay, plus c, or you can say 2 gets cancelled. You can say 10x by 2 plus x plus c. This is the correct answer for integral cos x 1 plus cos x dx. Okay, now the given question, integral 1 upon 1 plus sin x cos x, we need to solve with the help of Weierstrass substitutions. Okay, this integral. Now for these type of integrals, we have to substitute this standard, this t equals to 10x by 2, or you can write here, so to substitute, put t equals to 10x by 2. If you do this, differentiate dt equals to what? Or you can say x by 2 dt equals to differentiation of sec is what? 10 is what? Sec square x by 2. Okay, and then dy dx of x by 2 is what? 1 by 2. Okay, so therefore dt, I need dt in terms of what? In terms of x. Okay, this is dt same as into dx. Okay, so I can send sec square down. So therefore dt is same as sec square is what? 1 plus 10 square x by 2. Okay, here 1 plus 10 square x by 2 is what? 1 plus t square. Okay, these 2 I can send here. 2 is same as dx. Okay, here you can write dx is this. Okay, similarly I need sin x cos x. Okay, Sine x, therefore again this is dt dx here, okay. Again sine of x is what? 2 tan x by 2 upon, in terms of 10, okay, 1 plus tan square x by 2, okay. Now if I substitute tan x by 2 is equals to t, then it will be what? Sin x is 2t upon 1 plus t square, okay. Similarly cos x is what? 1 minus tan square x by 2, similar, and 1 plus tan square x by 2, and these standard formulas we have, okay. We have to use this standard formula at this integral, okay. By substituting this, we have is equals to integral 1 upon 1 plus sin x. Sin x is what? 2t upon 1 plus t square, plus cos x is 1 minus t square upon 1 plus t square, and dx is what? 2 upon this, okay. 2 upon 1 plus t square dt. In some question they have written 1 instead of plus. If it is minus is there, same process, you have to put minus here, okay. So I am solving 1 plus sin x plus cos x. Similarly, the same sums, same way you can solve 1 minus sin x plus cos x also, okay. Now if I take LCM, this denominator term, what I have is, I have 1 plus t square, okay. Here 1 plus t square into 1 is 1 plus t square, plus I have only 2t plus 1 minus t square, because 1 plus t square I am taking. This is 1 plus this into this is 1 plus t square, 2t I have, again here 1 minus t square, okay, into 2 upon 1 plus t square. This 1 plus t square and 1 plus t square I can get cancelled. Otherwise you can take, you can do until you can bring off, and this one gets cancelled, okay. Again this t square plus t square and minus t square gets cancelled, okay. So what I am having is integral of these two, I'll write over here, 2 upon 1 plus 1 is 2, t square gets cancelled, I have plus twice t, okay. What are remaining? 1 plus 1 is 2, t square plus t square minus t square gets cancelled, 2t I am having here, this gets cancelled, 2 is there, okay, into dt. Now from numerator I have 2, from denominator I can take 2 common, okay, that 2 upon 2 gets cancelled, okay. Here I am sending 2, 1 upon 1 plus t. If I take 2 common from here, okay, 2 into 2t, from here 2, okay, these 2 and these 2 gets cancelled. Here I have dt, okay. Integration of this is what? Now if you differentiate 1 plus t, you are getting 1, okay. Therefore that is log of 1 plus x, 1 plus t, okay. This is what? Log of 1 plus t plus some constant, okay. What is t? You have to compare, okay. T is what? Our tan x by 2, that is log of tan x by 2 plus c, okay. This is the required answer for this, okay. Now if question is like this, okay, if the question is like this, for example, if the question is, if they have given minus, okay, what you have to do is same substitutions, okay. Now I will get minus over here, I will get minus over here, okay. So if I get minus over here, so I will get this into LCM is this, so I will get minus 2t over here, I will get minus 2t, okay. 1 plus t square, all everything same. Here, instead of t square gets cancelled, 1 plus 1, 2. Instead of plus 2, I will get here minus. Instead of plus, here I will get minus. Okay, now here. Now differentiation of, look at here, 1 upon 1 minus t is, I need minus, okay. So I can write one step over here. This is same as, I can say minus 1, I can say minus 1 minus t dt. Why? Because differentiation of 1 minus t is what? Minus 1, okay. I need minus 1, this minus 1 gets cancelled. Therefore, I need to adjust this minus, okay. Minus plus. For this, okay, we have, will be what? Minus, already have minus, minus 1, log of 1 minus t, okay. Here, we have 1 minus t, here we'll have minus, okay. And 1 minus t, okay. Here previously you have to have 1 minus 10x by 2, okay. In the previous also, I think I forgot to write 1. Here also you have to write 1, okay. 1 here minus 10x by 2 plus c, okay. Now integral of 1 upon 2 plus cosx dx, we have to solve this with the help of Weierstrass substitution, okay. Now in the previous lecture, I already explained we have to substitute t equals to 10x by 2, and if you differentiate dt, you will get this, okay. I already explained in the previous lecture. This we need to, dx we need to have this, okay, dx in terms of t, sin x in terms of t, cos x in terms of t, we have to use this one, okay. Now since cos x even, we will use cos x and dx, okay. Now this is same as, by substituting this, integral 1 upon 2 plus cos x is what? 1 minus t square upon 1 plus t square. What is dx? Dx is 2 dt upon 1 plus t square, okay. From here, okay, all these substitutions you can see my previous lectures how derive, okay, from the Pythagorean theorem, or you can say from the trigonometric triangle, okay. Now if I take LCM this, what will come? Here 1 upon, here 2 into 1 plus t square plus 1 minus t square upon 1 plus t square into twice dt upon 1 plus t square, okay. Now this 1 plus t square I can send up, okay. Here I can write 1 into 1 plus t square is same as 1 plus t square. I am sending 1 plus t square up, okay. Now this is same as, and 1 plus t square gets cancelled, okay. Here I will have 2 dt upon multiplied 2 into 1 is 2 plus 2 into t square is twice t square plus 1 minus t square, okay. Here 2 into 1 is 2, twice t square, 1 minus t square. This is same as 2 dt upon, what is t square? Here you have plus t square minus t square, you have only t square. 2 minus 1 is 1, t square. Here you have 2 plus 1 is 3, plus 3, okay. Now these two I can send outside, 2, I can write 1 here, okay. And I want to apply of this from integral of 1 upon x square plus a square dx is, we have 1 upon a tan inverse x by a plus c, okay. This formula I want to apply this here, okay. This is already from this, but I need to get this square. We have x square, variable t square, but I need to get 3 square, okay. 3 is same as root 3 the whole square, because root square root and square gets cancelled, okay. This become a what? A. Therefore 1 by a. So here our a is what? Root 3. So 2 already have. Therefore 2 upon 1 by a means what? 1 by root 3. Tan inverse x by a. What is x? Our t. A is what? Root 3 plus c. Okay. What is our? You have to come back. What you have to substitute? What is t? T is what? 10x by 2. Okay. Here, this is tan inverse 10 of x by 2 upon root 3 plus c. Okay. This is the answer for this one, integral 1 upon 2 plus cos x.